When you see a vehicle traveling at highway speeds, the immediate impression is one of raw mechanical power, pistons, gears, and combustion. But beneath the metal body panels, a modern vehicle operates as a highly decentralized computer network. At the center of this network sits the Engine Control Unit, or ECU, solely as a mechanical wear part, ignores how the vehicle's internal logic actually functions. A roadside blowout immediately shifts the vehicle's physical geometry. To safely restore that geometry, automotive technicians rely on a strict industry benchmark known as the 3% tire rule. The parameter is absolute. A replacement tire cannot deviate by more than 3% in total height from the original factory specifications. If a stranded driver installs a tire that violates this variance, they corrupt the data stream being sent back to the ECU. A physical mismatch of just a few fractions of an inch creates a data conflict that begins to desynchronize the vehicle's active safety net. To understand why a replacement is sometimes mandatory, we have to look at the exact moment a tire strikes a nail. A tire's architecture is divided into two distinct zones. The first is the center tread area, which makes contact with the road. This section is backed by rigid steel and fabric belts. Because these belts provide high structural stability, a center tread puncture of up to 1/4 inch is safely repairable with a plug. The internal belts hold the repair firmly in place. The sidewall operates under different physics. It acts as the vehicle's load-bearing tension backbone. To support weight and dissipate heat, it flexes thousands of times per mile. A plug inserted here triggers interply shear. The internal layers rub together, physically ripping the repair apart. Because of this tension, sidewall damage can never be patched. It requires a complete precision replacement to maintain your safety on the highway. Historically, a driver would simply install their spare. But to save weight and hit fuel standards, most manufacturers have eliminated physical spare tires entirely, forcing drivers to source roadside replacements. The ECU measures movement by calculating rotations per mile. Here, a factory-spec tire rolls next to a 4% taller mismatched tire. With its larger circumference, the taller tire completes fewer rotations over the exact same distance. This slower rotation data is instantly transmitted back to the ECU. The computer processes this input and makes a logical but incorrect conclusion. It assumes the vehicle is traveling slower than its actual ground speed. This error immediately impacts the dashboard. The speedometer displays an inaccurate, slower reading to the driver. Furthermore, the ECU uses this speed data to govern the transmission's shift points. With the math thrown off, the transmission shifts at the wrong intervals, resulting in sluggish performance and increased internal wear. What feels like a mechanical transmission issue is actually the direct result of localized physical data corruption at the wheel. That wheel data also feeds into the vehicle's active safety systems, which require hyper-accurate telemetry to stage real-time computational interventions. The anti-lock braking system, for example, relies on this exact data to rapidly pulse the brakes and prevent skids during an emergency stop. Misinterpreting the mismatched tire's slower rotation, the ECU fails to properly pulse the brakes. This danger multiplies with electronic stability control, which actively balances the car during a slide. The system incorrectly flags the mismatched tire's speed variance as a severe loss of traction. Acting on this false data, the system applies the brakes to the wrong wheel, inducing a loss of control. Ignoring the 3% rule during a roadside replacement turns the vehicle's own safety sensors into an unpredictable liability. The industry reflex to a roadside flat is to immediately call for a flatbed tow truck. But loading a modern car onto a flatbed requires a heavy metal tow cable that can stress sensitive electronic drivetrains and low-profile suspension systems. Towing introduces mechanical risk and logistical friction. It moves the vehicle without actually addressing the ECU's precision data requirement. A mobile-first approach treats a breakdown differently. It addresses the failure as a hyperlocal technical intervention rather than a transport event. Resolving the structural tire issue exactly where the vehicle sits is the only efficient way to preserve both the mechanical and digital integrity of the asset. This three-step operational workflow begins with the request intake, capturing exact location and diagnostic data. Step 2 is tech dispatch, deploying a mobile unit carrying your factory-spec tire. Step 3 is on-site resolution, replacing the tire and instantly resynchronizing the ECU. By providing the correct tires for sale at the time of service, technicians guarantee the 3% rule is satisfied before the engine is ever started. This level of precision mobile recovery is executed daily by regional specialists operating across the North Carolina Piedmont. If you are stranded along the I-40 or I-85 corridors, bypass the tow truck. Contact I-40 Roadside Assistance directly for precision mobile tire service. Call 336-898-1570. Request dispatch online at i40roadside.com/tire service or find them via their Google business profile.